CAIE A-Level Maths Summer 2020 Paper 1 Variant 1 Question number 2. In this question, it is given that in the following equation, the coefficient of the 1 upon x term is 74 and we have to find the k value. If we look at the equation carefully, there is a plus sign in the middle of the equation, which means that we will have to treat these two imaginary boxes separately. So we can write this down as kx plus 1 upon x to the whole power of 5 plus 1 minus 2 upon x to the whole power of 8 equals to 74 into 1 upon x, because 74 is the coefficient of the 1 upon x term. Now if you look at the equation carefully, there is an x value in the a term, the a value, there is an x in the b value as well, and in the second box you also have an x value in the denominator of the b term. So if we have to expand this equation by the traditional means, it will take up a lot of space and a lot of time, because we don't know where in these particular equations the 1 upon x term lies. So what we can do to get around is we can expand this using the formula and isolate the x values and use that to find the r value, and we can use that to take out the particular term which we want, which is 1 upon x, and take it out from these terms and use it to our advantage. So to do that, we'll first apply the binomial formula on each of the boxes that we imagined, and this will give us 5CR, because r is unknown. It will be 1 upon xr and kx into 5 minus r. For the second box, it will be again 8CR, because r is unknown, minus 2 upon x to the power of r and 1 into 8 minus r. And this will all be equals to 74 into 1 upon x. Now if we isolate these terms, we can see that there's a x value over here and we have the x value over here. We need to isolate these x values from these equations. So we can write this as x to the power of 5 minus r upon x to the power of r equals to 1 upon x. And in a second box, we can do the same, as there's an x value in the denominator, so we can write this as 1 upon x to the power of r equals to 1 upon x. If we solve this further, we will have x to the power of 5 minus r equals to x to the power of minus 5 using the laws of indices. So this will further give us 5 minus 2r equals to minus 1, or 2r equals to 6, and we get r equals to 3. So we know that the 1 upon x value in this bracket, in this equation, lies in the r equals to 3 value. And in the second box, this is easier, and we can just write this as x minus r equals to x power of minus 1. Minus r will give us minus 1, and the final answer will be r equals to 1, which is the first value in this equation. So if you copy down the formula from above, we can write this as 5C3 1 upon x cubed into kx. 5 and x will give us squared. Let's apply the brackets, a plus sign, and this will give us 8c1 minus 2 upon x to the power of 1 into 1 equals to 7, close the bracket, and this will be equals to 74 upon x. If we solve this further, this will give us 10 into k square x squared upon x cubed plus 16 upon x equals to 74 upon x. This will be minus. Now we can cancel out the x and x values, x squared upon x squared, because we know that over here x cannot equals to 0 because this will not exist as this is undefined. So we cancel out the x values, and rearranging this will give us 10k squared upon x will give us 90 upon x. Okay, again cancel out the x and x values, and this will give us, we can also cancel out 10 and 90 for 9, and this will give us k squared equals to 9, or k equals to 3, or k equals to minus 3. But if we look at the question, we can see that the k is a positive value, so we can reject out this value, and the final answer would be k equals to 3.